Welcome back to my channel. In today's video, we are diving into a crucial topic for building robust APIs, error handling. Handling errors properly in APIs is important for improving user experience and making your API easier to work with for developers. So let's get into how to do it right. First, we need to talk about why. Let me just make it clear. Just remove it like that. Why error handling is important. So errors are a very important part of any system, including APIs. Whether it's a client sending an invalid request, the server encountering an issue, or external services failing, proper error handling ensures that first, developers using your API understand what went wrong. Second, the API remains reliable and predictable. Third, users receive clean, actionable feedback. So, good error handling improves developer experience and prevents frustration. So, there's other thing that's quite important is to using the right status code, because first things first, always use the correct HTTP status code to signal what went wrong. And let's give you some of them. First, for example, 400, which is a bad request. When the client sends a request that the server cannot process due to invalid syntax or bad request. Number two, 401. This is unauthorized. Authorized. The client must authenticate itself to access the resource. If you got 403, it's forbidden, which means the client is authenticated but does not have permission to access the resource. We have 404, which is not found. That means the request resource could not be found on the server. And lastly, 500, which is internal server error. It's a generic error when something unexpected happened on the server side. Number three, we need to talk about the consistent error response. So, consistency is key when returning error responses. Your API should always return errors in predictable format, so developers know how to handle them. And a well-structured error response typically includes three things. First, a clear error code or message. Second, detailed description. Third, which is a link to documentation or suggestions on how to fix the issue. So let us try to add a code block here. So in this code block, we will go with a bad example of how the error should be. This is a bad example of how the error should be. The good example, it should have the things that we did talk about before. First, we have the proper status code. We have a proper message, and we have the code for it. Okay. Next, we need to talk about the client side versus server side errors. When dealing with errors, it is important to differentiate between client side errors and server side errors. Let's make a quick one for it. So if we have any error that starts with 4, like 4 XX and whatever it will be, these errors are client-side errors, like sending bad data, missing authentication, or requesting something that doesn't exist. There is the errors that start with 5. These are the server-side errors. Something went wrong on the server, such as internal server error or unavailable service, which is 503. Okay, next. We need The other thing, that providing detailed error message. So when something goes wrong, your error message should be as detailed as possible without exposing sensitive information. The error message should help the API user understand first what happened, second why it happened, third how to fix it. If possible, provide steps or suggestions to resolve the issue. For instance, if we went previously, let me just make this small. If we went to our code here and look at this one, like for instance, if an email is missing in the request, and instead of returning 400, which is bad request only, we need to give a more detailed information to the client to tell him, her, or whatever they are about what get wrong. So the email field is required or is missing. Okay. Next, we need to talk about avoid exposing sensitive data. One thing to avoid when returning error message is exposing sensitive information. For example, if your server crashes or a database query fails, don't return the stack traces, internal database names, for example, or implementation details in your error response. These could be exploited by malicious users. And instead, return a generic 500 internal server error response and log the detailed error server side for troubleshooting. Okay, next we need to talk about the graceful degradation and fallback responses. In addition to HTTP status codes, it's good practice to include the custom error codes in your error responses. The codes can help API consumers debug issues more easily, especially when you have different types of errors that need to be um, distinguished. So first we might have like something like for this one 4001, which is mean invalid email format. This one means missing required field, and this one, for example, is database connection failed. Also, oh no, sorry. Okay, this should be this should be avoid. No, no, no. Okay, so let's continue talking about the graceful degradation fallback. So also in some cases, your API might depend on external services, and if those services fail, your API could return an error. And instead of letting your API break, implement a graceful degradation or fallback responses. For example, if an external server payment gateway is down, you need to return a clear error message like, what is the code? Let me just, uh-huh. Something like that. Payment gateway is currently down. Please try again later. Let me goes next. We did talk about that. We did talk about that. Logging and debugging. Let me delete that because we don't need it for now. So logging errors for debuggings and monitoring. While it is important to provide the clear errors to API consumers, it's equally important to log error server side for debugging and monitoring purposes. So we have like error details, time, occurrence, and request information. But be careful not to log sensitive data like passwords and stuff like that. Monitoring tools like Sentry or Datalog can help track and analyze errors in real time. So to wrap everything up, there are some keys to takeaways for error handling in APIs. First, use the correct HTTP code. Second, provide a constant and detailed error responses. Third, don't expose sensitive data. Fourth, include custom error codes for easier debugging. Fifth, implement fallback mechanism for external services. With proper error handling, your API will be more reliable, secure, and easier for developers to work with. So, that's it for this video, and see you in the future.